I'm the calculus professor, and today we'll be talking about U substitution. In problem number 49, we'd like to use substitution to integrate the integral from 0 to 4 of x over x squared plus 1 dx. All right, so what we're looking for here is a way to substitute so that if I take the derivative of the thing that I substitute for, it shows up in the integral. And I think that the closest thing we have here is the bottom. The bottom is x squared plus 1. So if I make a substitution for x squared plus 1, then du would be 2x dx. And I look over here and I'm very, very close, right? On top I have an x and I have a dx. So I have an x dx. I need a 2x dx. So what I'm going to do is I'll go ahead and add the 2 on top and multiply on the outside of this integral by a 1/2. So let's rewrite. If I do, I get the 1/2 on the outside times the integral from 0 to 4 of 2x over x squared plus 1 dx. All right, now it's in a perfect form to make my substitution. I have my 2x dx to become my du, and I have my x squared plus 1 to become my u. So let's move over here. This is equal to, the 1/2 is still there. Then I have integral of 2x dx all just becomes du on top. And on the bottom I have x squared plus 1, which is just u. So my whole integral boils down to 1/2 times integral of du over u, but I still haven't filled in my limits of integration. So I need to ask, okay, x's start at 0, so where do the u's start? Well, if x is 0, come up here, and I say, if x is 0, what is u? It's 0 squared plus 1, which is 1. And if x is 4, what is u? So I come up here and I say x is 4, so 4 squared is 16, plus 1 is 17. So instead of integrating from 0 to 4, now I'm integrating from 1 to 17. So now let's take an antiderivative. Antiderivative here, I've got 1/2 outside still. Antiderivative of 1 over u is the natural log of the absolute value of u. So this would be ln of absolute u. And then I'm going to evaluate that from 1 to 17. We can do that, and I get 1/2 of ln of absolute value of 17 minus 1/2 of ln of absolute value of 1. Which we could rewrite. This is 1/2 of ln of absolute value of 17, of course, is just 17, so we don't need the absolute value sign. Ln of 17. And then over here, ln of absolute value of 1 is ln of 1, which is 0. So we just get minus 1/2 times 0, which is 0. So I end up with 1/2 ln of 17. And that is the answer for this integral.